Welcome to the Quick Start tutorial series for Visual 3D Print 2015, brought to you by Microsoft. Today we'll be working with point clouds. We will perform the following basic steps to prepare point cloud data for 3D printing. First, we will launch Visual 3D Print and open the point file. Then, we will create a mesh model from the point cloud data. Then, we will repair the mesh automatically. After that, we'll perform a remesh and then smooth the mesh model. We will inspect the mesh using curvature and reflection line analysis. Then, we'll create slice curves from the mesh for inspection. After that, we'll select a 3D printer, fit the model to the printer volume, and then check for errors. Finally, we'll export the model to an STL file for printing. Let's begin by launching the Visual 3D Print 2015 module. From the Home ribbon bar, select the Application Manager icon from the Plugins pane. Check the box next to Visual 3D Print and then pick OK. You will see the Visual 3D Print menu appear on the Home ribbon bar. Drop down the menu and then select Browser. The Visual 3D Print browser will appear docked on the left of the screen. Now, select the Mesh Modeling ribbon bar and we see all of the Visual 3D Print command icons are located here. The Meshes pane contains Mesh Creation Tools. The Model pane contains Mesh Editing Tools. The Inspect and Modify pane contains Analysis and additional editing tools. The Repair pane contains various tools for fixing your mesh model. The 3D Print pane contains tools for fitting, checking, exporting, and printing your mesh to a 3D printer. Now, let's load the point cloud data for this tutorial. From the Visual CAD menu, select Open. Set the file type to point cloud star.txt files. Find the part file named rubberduck.txt located in the Quick Start folder and then pick Open. From the Translation Options dialog, select Comma under Delimiters and create Point Cloud under Options. Now pick OK to import the point file and then select the ISO View 1 to work in. In the browser, we see that we have one point cloud. To create our mesh model, we'll go to the Mesh Modeling ribbon bar and select From Point Cloud. We select the point cloud and then right-click or press Enter. Notice that an Options dialog appears below the browser. We'll accept the default options and then pick Create. From the browser, we see that we now have one point cloud and one mesh with over 23,000 triangles. From the Display ribbon bar, we'll select Shaded with Edges to see the mesh more clearly. Then we'll select the Option icon from the status bar to display the Options dialog, and then select Display. For Mesh Edges Display Style, we'll select All Edges. Select Apply and then OK to close the Options dialog. Then, from the browser, we'll turn off the point cloud by unchecking it and take a look at the mesh that was created. We notice that the point cloud data is incomplete, leaving the model currently incompatible for 3D printing. However, we can repair the mesh automatically. Now select AutoFix from the Repair pane of the Mesh Modeling ribbon bar. This will fix holes, self-intersecting facets, and more. Select the mesh model and then right-click or press Enter. We see now that all the gaps are closed. Next, we'll remesh the model, creating a more uniform mesh. From the Inspect and Modify pane, select Remesh. We select the mesh model and then right-click or press Enter to display the Remesh dialog. Selecting the Uniform method will remesh the model based on a fixed edge length. We'll then set the edge length to 0.125. We'll set the number of iterations to 4. Then we'll uncheck Keep Sharp Edges and then pick Remesh. We now see that each facet in the mesh model is uniform. Although the facets are uniform, we still see areas in the mesh that are rough. Let's smooth these out a bit. From the Inspect and Modify pane, select Smooth. We select the mesh model and then right-click or press Enter to display the Smooth dialog. We'll allow the vertex of each facet to shift in both directions, both inward and outward. This means that any smoothing will both add and remove facets as needed. Then we'll set the number of iterations to 4. This means that the second iteration will smooth the results of the first, and so on. Now we pick the Smooth button and review the results. We see that the mesh looks much smoother now. Next, we'll analyze the mesh model using a couple of different methods. From the Inspect and Modify pane, select Curvature. This will highlight areas of curvature across the model. We select the mesh model and then right-click or press Enter to display the curvature dialog. We'll leave the curvature type set to Mean and then pick Analyze to see the results. You can pick the Cancel icon to close the command dialog, leaving the mesh selected. Now, from the Inspect and Modify pane, select Reflection Lines. This method will indicate any irregularities or tangent discontinuities across the mesh. With the mesh still selected, we'll right-click or simply press Enter. We'll accept the default settings and pick Render to update the display and review the results. Again, you can pick the Cancel icon to close the command dialog, leaving the mesh selected. Next, we will visually slice the mesh model to simulate levels of 3D printing that will occur. From the Model pane, pick Slice. From the Slice dialog, we'll set the distance between each slice to 0.1 and then pick Slice. From the browser, first select the slice object and then uncheck the mesh object. The slice will be isolated and clearly highlighted on the screen. The browser displays information about the slice object. Notice that the checkmark icon is displayed, indicating that no open curves are present. If you right-click on the slice object from the browser, you can export it to actual curve geometry if needed. For now, we'll hide the slice object from view by unchecking it and display the mesh again by checking it. Now, we'll set up the mesh model for 3D printing. From the 3D Print pane, pick Select. From the list of predefined 3D printers, we select our target printer to be Maker Gear M Series. From the browser toolbar, select the icon to toggle the visibility of the 3D printer's volume. We now see it on the screen, but notice that the mesh is positioned outside of the printer's volume. Pick the Cancel icon to close the Select command dialog. From the 3D Print pane, select Fit. Select the mesh and then right-click or press Enter to display the dialog. For Z alignment, we select Bottom, and for XY alignment, we select Center and then pick Fit. The model is moved to the center of the 3D printer's volume. Now, let's check the mesh model to see if it's truly ready for 3D printing. From the 3D Print pane, pick Check. Select the mesh and then right-click or press Enter to display the dialog. Notice that the X icon tells us that the mesh model is not entirely within the printer's volume. Pick the Cancel icon to close the dialog, leaving the mesh selected. In VisualCAD, right-click on ISO View 1 and select the Quad Viewport option. We see that the mesh extends past the printer's volume on two sides. Let's rotate the model. With the mesh still selected, turn on the Graphic Manipulator from the VisualCAD Status toolbar. From the top viewport, select the Graphic Manipulator's Rotate Z. Enter 90 and then press Enter. This will rotate the mesh 90 degrees about the Z-axis. Now, select the Graphic Manipulator icon again to turn it off and then double-click on ISO View 1 to display only that viewport. Now we'll select Check from the 3D Print pane once again, select the mesh, and then right-click or press Enter. We see now that the model passes the printer volume check. Pick the Cancel icon to close the command dialog, leaving the mesh selected. Now we're ready to create an STL file to send to the 3D printer. From the 3D Print pane, pick Export. From the Save As dialog, set the Save As type to stereolithography binary star.stl files, and then pick Save. This file can now be sent to your 3D printer server or service center for printing. This completes Chapter 1 of the Quick Start tutorial for Visual 3D Print 2015, brought to you by Mexsoft. For further assistance, you can visit the online help supplied with the program or visit www.mexsoft.com for additional tutorials. Thank you.